the mean value theorem and monotonicity. Let's start with the mean value theorem. The mean value theorem, or MVT, states if you have a function that's continuous on a closed interval AB and differentiable on the open interval AB, then there exists at least one value c on the open interval AB such that the derivative at that c value is equal to the average slope. And so it's y2 minus y1 over x2 minus x1. So this is the slope at c, and it has to equal the average slope between the endpoints a and b. We can rearrange that formula and multiply both sides by b minus a, and you end up with f of b minus f of a, or the difference of the y's, equals the derivative of c times b minus a, which is the derivative of c times the difference of the x's. Notice how similar these two are and how similar they are to linear approximation. Monotonicity deals with whether or not a function is increasing or decreasing. Increasing functions have slopes that are positive, and decreasing functions have slopes that are negative. And we can take a look and see if a slope is increasing or decreasing by checking the first derivative. So, if you check the first derivative and you have a negative number, then the slope is negative and f of x is decreasing. If, on the other hand, you check the first derivative and you get a number greater than 0, then the slope is positive and f of x is increasing. You'll notice that if we found a function where it was increasing and then it became decreasing, or was decreasing and then it became increasing, at the point where it switches, we have either a maximum or a minimum, or we could have a maximum or a minimum. Those are called critical points, and there is a test called the critical point test. The critical point test, as I mentioned, deals with if the derivative changes from either positive to negative or negative to positive, we can end up with these local maximums and local minimums. So if the derivative changes from increasing or a positive slope to negative or a decreasing slope at c, then c is a local, and if it's positive and then becomes a negative, c would be a local maximum. If, on the other hand, the derivative changes from negative to positive, you would end up at c, you would end up with a local minimum. Example of the critical point test and using it to analyze a function. So in this example, we want to analyze the critical points of the function given 1/3 x cubed minus x squared plus x, and to analyze it we need to take a look at the first derivative, bring the 3 down, times 1/3 is 1, x squared minus 2x plus 1. And what we want to know is when is this equal to 0? Because on each side of that it's going to be either increasing or decreasing. So we make this equal to 0, solve this through factoring, and this function has a double root as x is equal to 1. And so I want to know, okay, well, I know what's happening at 1. At f of 1, my slope is 0. But what's happening on each side of 1? At f of 0, what's happening? and into the derivative, I can see that the slope is 1. And what's happening on the other side at f of 2? Well, 4 minus 4 plus 1 is also 1. So although I have a point where my slope is equal to 0, which should be either a minimum or a maximum, on this side I have an increasing function, and on this side I have an increasing function. And so the critical point test requires us to have one increasing and one decreasing so that you can see, oh, I've got a local min or a local max. And what's actually happening with this graph, if you go and sketch it, is you've got at 1 a tangent line of 0, but it's increasing on both sides of tangent equaling 0 at 1. And so the critical point test shows you that you don't have a local max or a local min in this case. So you do need to go through, find out when the derivative is equal to 0, and then you can test on each side and see if it's increasing or decreasing. But it won't always be a local max or a local min. Sometimes it will just be what we call a critical point. So you're free now to go take a look at the pre-class questions on the MVT and on monotonicity and critical point test.